our mean electrical axis. So what this is the overall general direction that most of the electrical activity in the heart is traveling. So normally we do expect that to be about where lead 2 is, going down towards the apex of the heart. We would call this a normal axis deviation because it's landed in this bottom right quarter of our circle. This is a picture from your lab guides. You should recognize it. And I'm just going to speak to those leads that we call biphasic leads. So they're listed there in that top corner. So lead 1 and AVF are at 90 degrees exactly from each other. And so we call them biphasic. Now, the reason that we're interested in them is because the amplitude, which is how tall that spike is, can tell us which of those two leads the electrical activity is running closer to. So in this scenario, where our apex is and where our arrow is pointing is actually much closer to AVF than it is to 1. So what I would expect to see is that AVF would have a really big spike compared to lead 1 having a smaller spike. So the amplitude would be greater in AVF because the electrical activity is going closer towards that lead than it is to lead 1, which will have a lower amplitude. So that's normal. We do, of course, have abnormal ones, and the first one we'll talk about is right axis deviation. Now, I'll just put my camera back on for a moment because what we want to think about is that our heart doesn't sit in our chest like this. It sits a little bit more off to the left, like that, okay? And that's our normal axis position. Now, the heart isn't completely fixed to the chest wall. It's actually only secured by the great vessels up here. So if I lean to my right, my heart might actually twist around a little bit that way, and I could induce a right axis deviation by doing that. And likewise, if I lean more to my left, my heart might twist around a little bit more that way, which could change the overall direction of our mean electrical axis. This is what that might look like with the arrow. And so that arrow has actually landed in the bottom left quadrant of the circle now. And so we call it a right axis deviation. So we just want to be able to identify which of these 4 quarters of the circle that electrical activity is headed towards or ending up in. So again, in this one, that arrow is a lot closer to AVF than it is towards 1. And because it's going towards AVF, we still have a positive inflection there, and I would expect it to be quite large. Whereas we're actually moving away from lead 1 overall, and so lead 1 will have a negative inflection, and it will probably be relatively small. So that is our right axis deviation. We now have our left axis deviation, in which our electrical activity looks something like this and ends up over in this top right quadrant of the circle. Now you can see that this one is of course going much closer to lead 1, and so we would expect that to have a higher amplitude or inflection than what we would see in AVF, which it's moving away from. So the inflection will be negative, but it will also be a little bit smaller. Then we also have our extreme axis deviation, which is the last piece of the pie that we haven't looked at yet. Now, this is the top left-hand quarter, and for this to happen, we've got something pretty serious going on in the heart. Perhaps the electrical activity from the SA node has tried to go through, but there might be damaged tissue here that's blocking the electrical current from flowing nicely through the heart, and it might actually be bouncing back and ending up in this upper left quadrant. So we call that an extreme axis deviation. In this course, we refer to it as extreme right axis deviation, but if you just remember it's the extreme one, you should be okay. Of course, we are moving away from lead 1 and away from AVF, so we're expecting both of those leads to be negative, which tells you that we end up in this upper left quadrant. And of course, because we are moving away from lead 1 and away from AVF, we're expecting that both of those are going to have negative inflections in the leads. Okay, you got this.